A NEMA 17 stepper motor is being used to rotate a 1018 carbon steel precision Acme lead screw. A matching flange is connected to both the lead screw and the piston that will exert some force for a specific device application. What is the maximum linear force that can be developed by this setup? This is the first example for the power screw's main video, link below. In that video we learned that the linear force that a nut wrapped around the power screw can develop in the direction of the axis of the screw depends on the torque that the screw is subjected to. The reason we might be interested in that maximum force might be, for example, that the piston is connected to a hydraulic system. So in case something down the line of the hydraulic tubing gets stuck, we would like to make sure that the built-up pressure will not damage our equipment or make the tubing come off of the piston. Solving for the force from the expression that we derived during the main video, we see that we need the information about the mean diameter, the lead, the coefficient of friction, the angle alpha, and in the case of the maximum force, the maximum input torque. For an Acme profile, we note that alpha is half of 29 degrees. The lead will depend on the number of threads and the pitch or the distance between crests. If it's a single threaded screw and there's 10 threads per inch, the pitch is 1/10 inches, and for every turn of the screw, the nut advances 1 pitch, since it's single threaded, which means that the lead is equal to the pitch. For an Acme profile screw, the height of the threads is equal to a pitch over 2, which means that the mean diameter is equal to the nominal diameter minus 2 times 1/4 of the pitch, 1 on each side. The friction coefficient between lubricated steels can be assumed to be 0.15, and the maximum torque that goes into the screw will be determined by the stepper motor. When something gets stuck down the hydraulics line and the screw is not able to rotate, meaning its speed is equal to 0, the maximum torque that the stepper motor can generate is what is known as the stall torque. With a little bit of unit conversion, and knowing that every other unit is in inches and I probably want the force in pounds, we find that the maximum possible generated force is equal to 156 pounds. Assuming, for example, a 1/4 inch inner diameter for the tubing, the maximum pressure would be a whopping 3,170 psi. For additional examples on power screws, make sure